Hello everyone and welcome all of you. Today in this class I am going to start exercise 1.3. This exercise based on subset and superset. In previous class already we have learned about subset and proper subset. Subset and proper subset. Again, I remind you what is subset and what is proper subset. Let A and B are two sets. If every element of the set A is also the element of set B, then A is called a subset of set B. It is denoted by A subset B. If every element of set A is also the element of the set B, and if every element of the set A is also the element of the set B, but every element of the set B is not an element of the set A, then A is called the proper subset of B and is denoted by A proper subset B. Now let's start exercise 1.3. Exercise 1.3, question number 1. Make the correct statements by filling in the symbols subset, proper subset or not proper subset. Make the correct statement by filling in the symbols proper subset or not proper subset in the blank space. Roman number 1. The set of the elements 2, 3, 4 the second set of the elements are 1, 2, 3, 4, 5. Here the elements of the set, the first set is also the elements of the second set. Here the elements of the first sets are 2, 3, 4. Here the elements of the second sets are 1, 2, 3, 4. Here every elements of the first set is also the elements of the second set. Therefore this set is a proper subset of this set. Therefore the first set is a proper subset of the second set. Number 2. X such that X is a student of class 11 of your school X such that X is a student of your school. The first sets are given. X has that X is a student of class 11 of your school. The second set is X has that X is a student of your school. So আমি তোমালোকৰ স্কুলৰ ক্লাছ 11ৰ যদি এটা ষ্টুডেণ্ট হয় তেৰা সেই ষ্টুডেণ্টটো কি হ'ব? তোমালোকৰ স্কুলৰ এটা ষ্টুডেণ্ট হ'ব। ক্লাছ 11ৰ এটা ষ্টুডেণ্টক আমি কি ক'ব পাৰোঁ? ক্লাছ 11ৰ এটা ষ্টুডেণ্টটো কি হ'ব? সেই স্কুলখনৰ এটা ষ্টুডেণ্ট হ'ব। তেতিয়া আমি কি হ'ব? দ্য ফাৰ্ষ্ট ছেট, দ্য এলিমেণ্ট অফ দ্য ফাৰ্ষ্ট ছেট ইজ অলছ' দ্য এলিমেণ্ট অফ দ্য ছেকেণ্ড ছেট। Therefore the first set is a proper subset of the second set. Next, number 7. X such that X is an even natural number. X is an even natural number. Next, X such that X is an integer. X such that X is an integer. We know that the even natural numbers are 2, 4, 6, 8. The x is an integer. We know that the integers are, the elements of the integers are -2, -1, 0, 1, 2, 3, 4, 5. Here, every element of the set A is also the element of the set of the second set. Every element here, every element of the first set is also the elements of the second set. Therefore, this set is a proper subset of these sets. Therefore, we can write the first set is a proper subset. Proper subsets. This symbol is called proper subset. Proper subset of the second sets. Next, question number 2. Examined whether the following statements are true or false. Number 1, 2, 1. Examined the statements are true or false. A comma B is not a proper subset of the set of the elements B, comma C, comma A. Here, the elements of the first sets are A, comma B, and elements of the second sets are B, comma C, comma A. Here, every element of the set of the first set is also the elements of the second set. Therefore, the first set is a proper subset of second set. Therefore, this statement is false. This statement is false because the first set is a proper subset. The first set is a proper subset of the second set because every element of the set A is also the element of the second set. Therefore, this set is a proper subset of this set. Therefore, the statement is false. Next, number 2. A comma E, proper subset X such that X is a vowel in English alphabet. In the English alphabet. We know that the vowel in the English alphabet are A, E, I, O, U. A, E, I, O, U. Here, every element of the set, the first set is also the element of the second set. A, E. Therefore, the first set is a subset of the second set. The statement is true. The statement is true because this set is a proper subset of these sets. Because every element of this set is also the elements of these sets. Next, number 3. Roman number 3. 1, 2, 3. Proper subset 1, 3, 5. Here, the elements of the first sets are 1, 2, 3. 1, 2, 3, 5. Here, the 2 is the elements which belongs to the first set, but the elements 2 is not belongs to the second set. Therefore, every element of the first set is not a element of the second set. Therefore, this is not a proper set of these sets. Therefore, the statement is false. 1. The first set is not a proper subset of the second set. Because the elements, every element of the first set is not an element of the second set. Therefore, this statement is false. Next, question number 3. Let A equal to the set A of the elements are, question number 3, A equal to elements, the set A, the elements are 1, 2, 3, 4, 5. Here total number of these sets are 4. Here the total number of these sets are 4. The elements are 1, 2, 3, 4, 5. Here total number of elements of these sets are 4. The elements are 1, 2, 3, 4, curly brackets 3, 4, 5. Which of the following statements are incorrect and why? Number 1, Roman number 1, 3, 4, proper subset A. Curly bracket 3, 4 is a proper subset of A. This statement is false. This statement is false because 3, 4, the elements, this is the elements. These elements belongs to set A, but these elements not. This is not a set. Therefore, this statement is false. Next number 3, 4 belongs to A. This statement is true because these elements belongs to the set A. These elements belongs to the set A. Therefore, this statement is true. Next, number 3, set of the elements 3, 4 is proper subset A. This statement is correct because this set is a proper subset of set A. Next, question number 4. Write down all the subsets of the following sets. Write down the following subset. Write down all the subset of the following sets. Number 1. We know that if A has n elements, we know that if the set A has n elements, then the total number of elements, the total number of subset of the set A is equal to 2 to the power n. Remember, if A has n elements, then the total number of subset of the set A is equal to 2 to the power n. Again, I repeat, if A has n elements, then the total number of subset of the set A is equal to 2 to the power n. Let A equal to curly bracket A is a sets. Here the total number of elements is equal to 1. Therefore, the total number of subset of A, the total number of subset of A is equal to 2 to the power 1, because here total number of elements is equal to 1, is equal to 2. Here the total number of subset of set A is equal to 2. Therefore, the total subsets, therefore the subsets are, therefore the subsets of A are phi, set A. We know that phi is a subset of all sets. We know that in previous class we have learned phi is a subset of all sets, and phi is a subset of all sets. Therefore, the subset of set A are phi, set A. Next, number 2, A, B. Let A equal to A, B. Here the total number of elements, here the total number of set A is equal to 2. Here the total number of elements of the set A is equal to 2. Therefore, the total subset of these sets is equal to 2 to the power 2 is equal to 4. We have the total subset of these sets is equal to 4. Therefore, the total subset of set A are, therefore, the subsets of set A are 5. We know that 5 is the subset of all sets. 5, comma A, comma B, comma A, comma B. The subset of set A are, the all subsets of set A are 5, comma set A, comma set B, comma set A, comma B. Next, number 3. A is equal to 1, 2, 3. Here, the total number of elements. Here, the total number of elements of set A is equal to 3. Here, the total number of elements of set A is equal to 3. Therefore, the total subset of set A is equal to 2 to the power 3, equal to 8. Here, the total subset of set A is equal to 8. Therefore, all subsets of set A are 5, 2, 1, 3, and 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 2, 3, 8. The all subset of set A are this. Question number 6. Write the following as an intervals. Question number 6. X such that x belongs to R means real number, -4 less than x less than 6. We know that if A less than x less than B, then we can write open interval A, comma B. Know that if A less than x less than B, then we can write open interval A, comma B. Next, if A less than equal x less than equal B, then we can write close interval A, comma B. Number 3, if A less than x less than equal B, then we can write open interval of A, comma B. We can write open A, comma B, close interval. Number 3, if A less than equal x less than B, then we can write, remember these 4 points. If A less than x less than B, then we can write close interval, open interval A, comma B. If A less than equal x less than equal B, then we can write close interval A, comma B. Next, if A less than x less than B less than equal B, then we can write this, and if A less than equal x less than B, then we can write this. Here, x has that x belongs to R and -4 less than x less than equal 6, then we can write -4, 6. We can write -4, 6. Next, number 2. X such that x belongs to R and minus 12 less than x less than minus 10. Then we can write x such that x belongs to R means real number, and minus 12 less than x less than minus 10. Then open interval we can write open interval minus 12 comma minus 10. Next number 4, one number 4, x such that x belongs to R and 3 less than equal x less than equal 4. This can be written close interval 3 comma 4. Next number 7, write the following intervals in the set builder form. In the set builder form, given open interval 3 comma 0, we can write in the set builder form x such that x belongs to R means real number, and minus 3 less than x less than 0. X such that x belongs to R and minus 3 less than x less than 0. Number 2, close interval 6 comma 12. It can be written as x such that x belongs to R and 6 less than equal x less than equal 12. Next, number 4, close interval minus 23, open interval 5. This can be written as x such that x belongs to R and minus 23 less than equal x less than 5. Next, we will discuss exercise 1.4. This exercise based on union of sets, intersection of sets, and difference of sets. Exercise 1.4. This exercise based on union of sets, intersection of sets, and difference of sets. In previous class, we have learned about union, intersection, and difference. Again, I remind you, union of sets, intersection of sets, and difference of sets. Let A and B are two sets, then A union B, and denoted by A union B. Again, I remind you, A union B is the set of all elements of the set A and B. A union B is the set of all elements of set A and set B. Next, A intersection B. A intersection B is the set of all common elements of set A and set B. Next, difference of sets. A, and it is denoted by A minus B, is the set of all elements, which is belongs to only A but does not belongs to the set B, which is belongs to the set A but does not belongs to the set B. So let's start exercise 1.4. Exercise 1.4, question number 1, Roman number 1. Find the union of each of the following pair of sets. Roman number 1, the set x is equal to 1, 3, 5 and y is equal to 1, 2, 3. Find the union of these sets, and it is denoted by x union y is equal to, we know that x union y is the set of all elements of the set x and y. Therefore, the elements of x union y are 1, 2, 3, 5. Next, number 2, A is equal to A, comma, E, I, O, U, and B is equal to A, comma, B, comma, C. Therefore, A union B is equal to all elements of the set A and B. Therefore, we have A union B. The elements are A, E, I, O, U, comma, B, comma, C. This is the required answer. Next, number 5. Number 5. 1, A is equal to 1, comma, 2, comma, 3, and B is equal to 5. 5 is a null set. Null set means there are no elements. There are no any elements of set B. Therefore, A union B is equal to A. A union B is equal to A. Next, number 2. Let A equal to A, comma, B. A is a set of the elements. Number 2, question 2. A is a set of the elements A, comma, B, and B is a set of the elements A, comma, B, comma, C. Is A subset B is A proper subset B. What is A union B? Question number 2. Let A is equal to A, the elements are A, comma, B, and B is the set of the elements A, comma, B, comma, C. Is A subset B? Is A subset B? Solutions. We know that if A subset B, then if every element of set A is also the elements of the set B, but every element of set B is not the elements of the set A. Here, the elements of set A is also the elements of the set B, but the elements of every element of set B is not the elements of the set A. Therefore, A subset B. Here is A subset B. Yes, we can write A subset. A proper subset B. Next, what is A union B? Therefore, A union B, we know that A union B is the set of all elements of set A and B. Therefore, we have A, comma, B, comma, C. Next, number 3. If A and B are two sets such that, number 3, A and B are two sets such that A proper subset B, then what is A union B? Given A proper subset B, then what is A union B? What is A union B? What is A union B? If A proper subset B, then what is A union B? We know that A union B is a set of all elements of the set A and B. And here given A subset B, A proper subset B, that means every element of set A is also the elements of set B, but every element of set B is not an element of the set A. Therefore, we have A union B is equal to B. Therefore, we have A union B is equal to B. Next, number 4. If A is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, 6 and C is equal to 5, 6, 7, 8, and set D is equal to 7, 8, 9, 10. Then find A union B, Roman number 1. A union B. Already we have discussed A union B is the set of all elements of the set A and B. Therefore, A union B is equal to 1, 2, 3, 4, 5, 6. Next, number 6. Roman number 6. A union B union D. A union B union D. This is equal to A union B union D is the set of all elements of the set A, B and D. Therefore, A union B union D we have 1, 2, 3, 4, B 5, 6, 7, 8, 9, 12. This is the required answer. Next, question number 6. Question number 6. If A is equal to 3, 5, 7, 9, 11 and B is equal to 7, 9, 11, 13. C is equal to 11, 13, 15. Next, D is equal to 15. The elements are 15, 17. Then find Roman number 19. 6 Roman. Find A intersection B intersection B union C. Roman number 9. Find A intersection B. A intersection B intersection B union C. Solution. First, we will find out A intersection B. A intersection B. We know that A intersection B is the set of all common elements, all common of the set A and B. Therefore, A intersection B we have the elements are 7, 9, 11. 7, 9 and 11. Next, we will find out B union C. We know that B union C is the set of all elements of the set B and C. B union C. Therefore, the elements are 7, 9, 11, 13, 15. Therefore, A intersection B intersection B union C. Therefore, we have the common elements 7, 9 and 11. This is the required answer. Thank you.